We're going to wrap up lesson 9 by talking about compliments. Now, what is a compliment? We have often heard this in everyday life. Let me give you a few examples. Something is said to be a compliment if it completes it. For example, a hamburger is complimented with fries. Peanut butter is complemented with jelly. They just naturally go together. Two members of a married couple complement each other. I know that with me and my wife, she definitely is a compliment to me. We work well together and complete each other, if you would like to think of it that way. Now, with probabilities, complements have a similar idea. They are two concepts that work together and complete each other. In other words, one half and another half, that when you put them together, you get 100%. All right. So, for example, 85% of students like peanut butter, but 15% don't. These two are complements. Why? Because you have the 85% who like them, like peanut butter, 15% who don't. When you put them together, that adds up to 100%. That's everybody. All right. 21% of drivers text while driving. If that's you, shame on you. Shouldn't do it. But that's not the point of this video. So since 21% of drivers text while driving, 79% don't. So you have the 21% and 79%. When you put them together, that's 100%. That includes everybody. 65% of voters voted for one candidate, which means that 35% didn't. Why do I know 35? Because 65% plus 35% is 100%. So in probabilities, we're going to indicate it this way. We'll indicate an event with just a simple variable. For example, we'll say that we're dealing with event A. Then there are a few different ways that we can indicate the complement of A. We can say not A. We can say A with a bar over it. We can say A with a prime mark next to it, or we can say A with a little c as a superscript. All of these are common ways to indicate a complement. Generally in this course, I will use the A with a bar over it to indicate a complement, but I will call it not A, meaning those from my sample that are not in event A. All right. So A with a bar over it, but I will call it not A. All right. So in math, what's the relationship? Well, probability of event A happening plus the probability of event not A happening would be 1. That would be the probability of someone liking peanut butter plus the probability of someone not liking peanut butter. Those are the only two groups. You can put them together. That includes everybody, so it should equal 1. All right? So probability of A plus probability of not A is equal to 1. Now, if we solve for the probability of not A, then that would actually be 1 minus the probability of A. All right? Now, let's actually use this equation in these three scenarios. I already told you the answers for these. If you'd like to, pause it. Maybe you don't remember the answers. That's okay. Pause it and see if you can use the equation I just gave you. The probability of not A is equal to 1 minus the probability of A. Use that equation to solve these three questions. Go ahead and pause the video, see if you can do it. All right, this is what it should look like. 85% of students like peanut butter. How many don't? Well, if the probability of randomly selecting somebody who likes peanut butter is 85%, then the probability of randomly selecting somebody who doesn't like peanut butter would be 1 minus the probability of someone who likes peanut butter. So 1 minus 0.85. That gives us 0.15 or 15%. All right, 21% of drivers text while driving. How many don't? Well, the probability of someone who texts while they drive, so I'll call that P of T, probability of T for texting, is 0.21, that's 21%. Probability of randomly selecting a driver who does not text while they drive is 1 minus 0.21, which is 0.79 or 79%. 65% of voters voted for one candidate. How many didn't? Well, we do the same process. You've got the idea here. We take the probability of a voter voting for a candidate as probability of V, 65%. Probability of not V would be 1 minus 0.65, which is 0.35, 35%. That's the idea of complements. We're going to use a lot of complements in the next lesson, lesson 10, when we start talking about compound probabilities. But very important idea here, concept. We're going to see complements throughout the course.